Okay, so in 5.7 we're going to be learning another way to solve a quadratic equation by completing the square. So the ways that we've already learned is factoring, square root method, and then we use the quadratic formula. Okay, so on this first example, all we're going to do is we're given a trinomial and we're wanting to factor it. And it says that we're going to write it as a square of a binomial, which means that when we factor it, we're going to get the same two factors. Okay, so this first one, 3 terms, we want to find the sum and product. So your sum would be 24, the product would be 144. So again, we should be getting the same two numbers. So you're wanting to add to 24, multiply to 144. So that would be 12 and 12. So that would be x plus 12 times x plus 12. Since those are the same thing, I'm going to write it as x plus 12 squared. That's when it says square of a binomial. Okay? All right, so looking at the next one, we want the sum to be negative 12 and your product to be 36. So you're wanting to add to negative 12 and multiply to 36. So that would be negative 6 and negative 6. So that would be x minus 6. X minus 6, but again, we're going to write that as x minus 6 squared. Okay, so looking at part C, we want the sum to be negative 2, the product to be positive 1. So that would be negative 1 and negative 1. So I'm just going to go ahead and write it as x minus 1 squared. Okay, so D, we're having to look at some fractions. So the sum is 4 over 3. The product would be 4 over 9. So whenever we're multiplying, you know that we're wanting to get the same two numbers. So when we're multiplying the tops, and then we're multiplying the bottoms. So you're wanting to figure out what two numbers that you multiply together to give you a 4. So that would be 2. And then the same two numbers that multiply to give you 9 would be 3. So that would be x plus 2 over 3 squared. Okay, so we will use that information to complete the square. Now when you're completing the square, what you're trying to do is you're trying to find your c, which is your constant on a quadratic equation. So you're wanting to find that. In order to, when you factor it, you're going to get a binomial squared. So it says the words for completing the square: to complete the square for the expression x squared plus bx, you're going to be adding the new c by finding it. You're going to do b divided by 2, so you're going to half your b and then you're going to square it. That should give you your new c. So if we look back up at the top here, we have, look back at the top on A, we have 24 here. If we half 24, we're going to get 12, and when we square it, we get the 144. Same thing on B. When you half negative 12, you get negative 6. We square it, and we get 36. Half of negative 2 is negative 1. We square it, we get positive 1. And then same thing on the fraction one. Okay, so the algebra part of it, x squared plus bx, we're going to be adding that new c by halving b and then squaring it. When we factor it, it should give us the same two factors. And notice that up at the top, half of 24 was 12, and that's the number that we had inside our parentheses. Half of negative 12 was negative 6, and again, that was the number that we had inside our parentheses. So that's why it says b divided by 2 there. So when we write that as a binomial squared, it'll be x plus b over 2, and then you're putting the squared on the outside. Okay, so example 2, what we're going to do is we're going to find the value of c that makes the expression a perfect square trinomial, which means when you factor it, you get a square of a binomial. Okay, and then after we find that c, we're writing it as a square of a binomial. Okay, so to find c, we're going to half your b, which is 6, so that would give us 3, and then we need to square that, which would give us 9. So x squared plus 6x plus 9. When we factor that, you're adding to 6, multiplying to 9, so that should be x plus 3 squared. The next one, we want to half b, which would give us 6, and then we want to square that to give us our c, which would be 36. So when we factor that, that would be x plus 6 squared. Okay, so now we're going to, at the front, notice that when on the completing the square, your a, which is the coefficient of x squared, is a 1. And notice on information to actually solve a quadratic equation. So it says on example 3, solve x squared minus 10x plus 3 equals 0 by completing the square. Okay, so when you're completing the square, when you're using that method, the first step will be to get it in the form x squared plus bx. We want that to equal the constant, which is your number. So we need to subtract 13. So we end up with x squared minus 10x equals negative 13. So we move the constant to the other side. Now what we're going to do is we're going to complete the square on the left side like we were doing on the front, finding our c. So I'm going to half negative 10. So that would be negative 5. And then I need to square it, so that would give me 25. So x squared minus 10x plus 25. Now, if I'm adding 25 to the left side of our equation, we have to do the same exact thing to the other side. That's the most common mistake with completing the squares. You forget to add that to both sides because we want this equation to stay equal. So now the reason why we are using completing the squares, so that way we can factor it to a trinomial or a binomial squared. So when we factor the left side, that's going to be x minus 5 squared equals, that would give me 12. From here, this should look familiar. From here, you're using the square root method to get rid of the squared. So I'm going to take the square root of both sides. So those cancel, and I have x minus 5. And remember, we get a positive and a negative answer. Now 12, square root of 12. 12 is not a perfect square, but you need to use factor tree to see if you can simplify it. So 2 times 6, 2 times 3. And you're trying to find pairs. We have a pair of 2's, and then we have a 3 left under the radical. So I'm bringing out the 2, and then I have square root of 3. Okay, so from here, we're solving for x, so we're going to add 5 to both sides, and we're going to get x equals. Now notice 2 and 5, we cannot add those together because 2 has a square root of 3. So I'm going to put the 5 in front and then plus or minus 2 square root of 3. Since we can't add or subtract those two terms together, then that would be our answer. Okay, example 4, if you look back, number 4, it's not a 1. So you always want a, which is the coefficient of x squared, to be a 1 in order to complete the square. So we need to get rid of that 3. So what we're going to do is divide every term by whatever that coefficient is. So then we're going to have x squared minus 4x plus 9 equals 0. Okay, so from here, since we have a to be 1, now we're going to move our constant to the other side. So I'm going to subtract 9. So x squared minus 4x equals a negative 9. And now I will complete the square of the left side. So I'm going to half negative 4. So that's negative 2. And then I square it to give us a positive 4. Now if I add 4 to the left side, I have to also add 4 to the right side. Okay, so I should be able to factor the left side to a binomial squared now. So that would be x minus 2 squared, because negative 2 and negative 2 add to negative 4 and multiply to positive 4, and that would equal negative 5. Okay, so from here, take the square root of both sides. So you have x minus 2 equals a positive and a negative. And then notice we have a negative under the radical, so we need to bring that on the outside and make it an I. That's an imaginary number. And then I have the square root of 5. Square root of 5 is not perfect, and we can't simplify it using the factor tree. Okay, so I'll leave it in that form, and then I'll add 2 to both sides. Again, we can't add those 2 and I squared of 5, so I'm going to put the 2 in front, and then plus or minus I square root of 5. Okay, so let's look at this last example that we have. It says the area of a rectangle is shown. The area of the rectangle shown is 112 square units. You're trying to find the value of x. Okay, so we're talking about the area of a rectangle. The formula for that is length times width. So I'm going to plug into that. Area is 112. The length of this rectangle is 7x, and the width is x plus 6. So notice if we were to multiply 7x times x plus 6, we're going to end up with a quadratic equation. We're going to need to solve for x, so we're solving a quadratic equation. Okay, so you could use factoring, you could use quadratic formula. We're going to use completing the square, since that's what we're doing today. So that would be 7x squared when we distribute plus 42x. Okay, so since I'm using the completing the square, we want a, which is the coefficient of x squared, to be 1. So notice it's a 7, so I'm going to divide everything by 7. So that's going to give me 16 equals x squared plus 6x. Alright, so after we get rid of that coefficient of x squared, then we are looking to make sure that we have an x squared and x on one side, the constant on the other. Notice we already have that. If you would like to rewrite this as x squared plus 6x equals 16, that's fine. It gives you, it's the same thing. Okay? Alright, so I'm going to complete the square on the left side. So I'm going to half 6, which is 3, but then I need to square it. So that's going to give me 9. X squared plus 6x plus 9. And then make sure to also add 9 to the other side. So when I factor x squared plus 6x plus 9, I get x plus 3 squared. And then adding 16 and 9, that equals 25. From here, we're taking the square root. So you're left with x plus 3 equals a positive and a negative. Notice we have square root of 25. That is a perfect square. It equals 5. So subtract 3. We can actually add and subtract these two. So make sure you're doing positive 5 minus 3, which would give you 2. But also do negative 5 minus 3, which would give you a negative 8. Okay, so we were asked to find x. We can't have two different x values that we're plugging in order to find the length and the width, because we can't have two different lengths and two different widths. So if you notice, when you plug in a negative 8 in for x on the length, you're going to get negative 56? So negative 56. So that is not going to give you a negative answer. Okay? We can't have a negative length or a negative width. So in this case, whenever you're finding length and width, you're only going to be choosing that positive answer. So x equals 2. To check it, you could plug it in and make sure the length times the width after you find those two numbers gives you 112.